Now let's go to part C. Part C says that y equals to 10, and we are finding domain and range. So domain, remember, these are the values of x. So what we do here, if you look at this equation here, it is independent of x. Independent of x. That means it does not meet the x-axis. So whatever the value of x is, the value of y is not affected. It still remains 10. And 10 is a real number in the real number system. That means in this case, our domain is simply a set of all real numbers or real values, because we have said that domain is a set of the values of x. So for any value of x that we substitute here, the value of y will always be 10. So therefore, domain is a set x which comprises of x as real numbers, and this is the set builder form, set builder notation. What about in the interval notation? It means x, or the domain, are the values of x from negative infinity up to positive infinity. So this is the domain for this question. What about the range? If you look at this question, we have said it is independent of x, so there is no x here. That means this function is not affected by change in x, and that's why we said any value, any real value of x gives us the domain. Now the range is always going to be 10 regardless of the input value of x. Therefore, our range will always be 10 irrespective of any value of x that we substitute there. Our range will always be 10. Now this range has a definite value which is 10. So irrespective of the value of x, the value of y, which is the range, will always be 10. And this is the solution to part C. And lastly, part D, for example 1, we are going to find the domain, and if you look at this linear equation, y equals to negative 15, which actually means that there is a line cutting the y-axis at negative 15. So still, this function or this equation is independent of x. It is parallel to the x-axis, or it does not meet the y-axis. Sorry, it does not meet the x-axis, but it cuts the y-axis at negative 15. So the domain, which are the values of x, are the values when we substitute here give us the real value of y. So, but if you look here, we have said it is independent of x. So regardless of the value of x, y will always be a real number negative 15. This means that the domain, which is a set of the values of x, is a set of all real numbers. Any real number that we substitute here as x will always give us a real value of y, which will always remain negative 15 because the equation is independent of x. That means here, in the set Bueller form, the domain x is a set of real numbers. This is set Bueller notation or set Bueller form. If you want to state it in the interval notation, it means the real numbers will run from negative infinity up to positive infinity. This is the interval notation. So that is the answer for the domain. How about the range? We have said that range are the values of y, remember, which are well defined by the domain. So if you look at this equation, y equals to negative 15, we have said regardless of any value of x, regardless of any real value of x that we substitute, the range or the values of y will always be negative 15. Therefore, our range is a definite value, negative 15, which is independent of x. And therefore, this is the answer for range and the overall solution to example 1 part D, and we have come to the end of example 1. If you have any questions, please leave them in the comment section. Thank you.